And we are going to start with problem H. So these are no calculator problems. Either at the end of today or tomorrow, we will get to the calculator problems, but these are still no calculator. So letter H looks like this. Now it's been a couple of weeks since we did this. Does anybody remember what step 1 has to be? You got to divide by this number. You have to get rid of this number so that all you have is the thing with the exponent. So I'm going to divide both sides by 27. So I have 1/3 to the x equals 243 over 27, I think is 9. I'm going to double check that. Yeah, that's 9. And now you'll recall, this is a little tricky. We're jumping right in with both feet here. This is a little tricky, but you have to make both of these have the same base.
What page are we on?
We're on page 28, problem H. Right where we left off. You should have your notes completed up to that point. Now, I don't think there's any question. When you see a 9, I hope you think 3 squared. I hope that's what you think when you see a 9. Now, 1/3 is a little bit tricky. It's got a 3, but it's not 3, it's 1/3. What kind of exponents give me 1/?
Negative.
Exactly. So I'm going to change this 1/3 into 3 to the negative first, because 3 to the negative first is the same as 1/3. And remember, kids, I'm trying to make these two numbers match. That's the key. These two numbers have to match. So I already decided, because I had a 9, I was going to make that 3 squared. So then I had to take my 1/3 and make it 3 to the negative first, and of course that x is still there. As soon as you make these numbers match, then you can set the exponents equal. So negative 1x equals 2. As soon as the bases match, you can set the exponents equal. I hope you're kind of remembering that from the work we did before. So that means your answer is negative 2. So the answer to problem H is negative 2. That's about as tough as our problems are going to get, guys. That's a little bit tricky. The next one is not so tricky, so let's take a look at it. Who can tell me what the first thing I have to do is? Right, stop. What did I do first over here?
Divide.
Exactly. Now, the number I have to divide by is a fraction. So if you want to divide by 1/8, that's perfectly okay, but it might be easier to multiply by 8. Would that accomplish the same thing? Instead of dividing by 1/8, I will multiply by 8. So that 2 to the x over 5 equals 64. Move this number, whatever it is, get it over on the other side. Get rid of it. Now, 2 is 2. I can't really do anything with 2. But that means that I have to write 64 as 2 to a power, because again, these numbers must match. So if I'm going to leave this a 2, which I really don't have any choice, then I'm going to have to rewrite 64 as 2 to a power. Does anyone happen to know what power of 2 64 is?
4.
No, close. 2 times 2 times 2 times 2, that would be 2 to the 4th. That is 16.
Would it be 6?
It is 6. It is 6. Because another 2 would give me 32, so I need another 1 to get 64. It's 2 to the 6th. Now, I told you this before, and I'm standing by it. It really is a good idea for you to be familiar with those numbers. If you're not, though, it's okay. You'll just have to figure it out. Once I decided to leave this a 2, then this has to become a 2. So 2, 2, 2, 2, however many 2's, got to give me a 64. So we figured out it's 6. Once these are both 2's, then you just set the exponents equal. And the answer to this problem is 30. Just multiply both sides by 5. The answer is 30.
Wait, Miss Ford.
Uh-huh. Yep.
How did you get 30?
If x over 5 equals 6, I'm going to multiply both sides by 5. I'm just solving that little equation. I got to multiply both sides by 5 to get x by itself. Now it looks way different, but the next problem is exactly the same. The difference is the way we start. Shoot. Let me see. We're going to start differently. Now this is a logarithmic equation. Guys, we can't solve logarithmic equations unless we change the way they look. Does anybody remember how we rewrite that equation? I'll give you a clue. Loop-de-loop. Oh my. Okay. Loop-de-loop means start right here. 7 to the x equals 49. When we rewrite a logarithmic equation, we take this number to this power equals this number. So 7 to the x equals 49.
This is 2, right?
So the answer is 2, yep. The answer is just 2. Because everybody hopefully knows that 7 to the second power is 49. There wasn't anything hard about that one. Let's see about the next one. Log base 2 of x equals 3. All right, let's loop-de-loo that. What does that say, David? If I loop-de-loo this, if I do exactly what I did over here, what equation would I have? Start right here.
Yeah.
So I'm going to start right here.
Okay.
2.
It's gonna go to the 3, right?
Yep. Equals x. 2 to the third equals x. That's the way it works. Well, that's easy. What's 2 to the third?
8.
Yep. So the answer to that one is just x equals 8. Now the next one looks a little bit bigger, but it is not done any differently. So Lainey Eisenberg, hello. Can you loop-de-loo this for me, Lainey?
I have no idea.
Okay, I want you to look at this problem right here. Are you looking at it?
Yeah.
Okay. Start right here with this number and take this number to this power and it equals this number. So 2 to the third equals x. So what's this one going to say? Do exactly the same thing.
4x.
4 to the second equals x plus 2. Start with the base number, raise it to this power, and it equals that thing. So 4 to the second equals x plus 2. 4 to the second equals x plus 2. Now, what is 4 to the second? Anybody?
Would
16.
X be 14?
And then I'm going to subtract 2, so the answer is 14. These are not hard problems, guys, but you've got to get this loop-de-loo down, because that's the only way to solve it. You have to rewrite it. All right, there's another one like this. Clara, loop-de-loo it. What's it say?
Sorry, don't you do like 3 to the 2
Exactly.
and equals 1 minus x?
That is exactly what we do. Very good. 3 to the second equals 1 minus x. Perfect. Now, 3 to the second we know is 9. Now be careful when you solve that. I mean, that's like a 7th grade equation, but it's kind of backwards, and if we're not careful, we'll mess it up. Let's subtract 1. So 8 equals negative x. So divide both sides so it looks like x equals negative 8. The next one has a little bit of a snag. Take a look at it. Does anybody have an idea about how we start? This one isn't going to start quite the same way as the last one because of what? What's different about it?
The 2 on the front.
Yeah, we got this 2 out here in front. Any idea how we might get rid of that?
Divide.
Exactly. So that's going to be gone. So I'm going to have log base 4 x plus 1 equal to 2. Remember those problems we started with when there was a number out in front? The first thing we did was divide it. The very first 2 problems we did today. This is exactly the same thing. If there's a number, a coefficient out in front, get rid of it. Divide it out. All right. Zane, can you loop-de-loo this for me?
Yeah. Wouldn't you do the 4 to the second power?
Equals, yep, 4 to the second power
16.
equals, yeah. Well, let's say 4 to the second equals,
X plus 1.
yep, that's exactly right. So x equals,
And then subtract 1 and get 15.
exactly. Very nicely done. We're getting the hang of it. These are not too bad. Oh, Lordy. Then look at the next one. Maybe I spoke too soon. Now, I want you just to look at it and think about how it's different than the other ones we did, and what might we do to make it look more like the other ones? Anyone have a thought?
Subtract the 6 to get where 0 is.
Perfect, Katie, thank you. So the first thing we want to do is move this 6 over to the other side. Beautiful. Now, Lindsay, do you have a thought about what might happen next?
Divide out the -3.
Exactly. So when I divide by -3, I'm going to have a 2 over here. Is everybody still with me? Kennedy, can you loop-de-loo it for me?
Yeah. So it'd be 6 squared equals 4 plus x.
Beautiful. And of course, we all know 6 squared is 36. So it looks like the answer to this problem is 32. Okay, so far so good? Yeah, those weren't bad. All right, Now you need your calculator. Because for part 3, I want you to notice there is a difference. Oh, wait. We have done, well, I'll leave that. We have done problems like that. 3 to what power is 9? That would be 2. Everybody knows that. This is different because 7 is not a power of 3. Would you agree with that? Yep. 7 is not a power of 3. So, if 7, or if this number is not a power of this number, then I'm going to need a calculator. So everybody's got a calculator ready. It's the only way to do the problems unless we use a table, a big book of tables, which we don't have. So we're going to use our calculator. First thing I want you to do with this is problem number 3A. I want you to put a log on both sides of it. Just stick log in front of both sides of it. The reason that we did that is because when you take the logarithm of something to a power, the exponent gets to come out in front. So the next step is going to look like this. When you have the logarithm of something to a power, the power is allowed to come out in front. So that means instead of it being up here, now it's down on level with the rest of the problem. And then I'll just divide both sides by log 3. And I will have my answer. Remember from before when we typed this in, it's real easy. We just type log 7, but as soon as you press log, it's going to put in a parentheses. You have to close it after the 7. So log 7, close parentheses, divided by log 3. Let's round to the 10,000th. That's what we did before. 1.7712.
Miss Ford, how did you get that?
How did I get what? The answer?
Yeah, how'd you put it in your calculator?
Exactly like it's written. Type it in exactly the way it's written right there and you'll get it.
Oh, over each other?
Yep. Divided by.
Thank you.
Yep. So let's look at the next one. Four to the x equals 10. All right, Jaden Scruggs, you awake?
Yeah.
Awesome. Now, using what we just did as a model, what do you think is going to be the first thing I'm going to do with this problem? This is number 2, or B, is letter B. What am I going to do with it?
Move the x.
Okay, I need to move the x, but I can't move the x unless there's what in the problem? What do I have to...
The word log?
Yeah, exactly. I have to take the logarithm of both sides. That's exactly right. So you stick log on both sides, and then, Jaden, you're exactly right. You can pull that exponent off. So x log 4 equals log 10. Do not be pulling the exponent off, guys, until you put the log in. The log has to be there. So as soon as he stuck the log on both sides, he could pull his exponent down. And now, Ella, what will be our last step? What do we need to do to get x by itself?
Divide by log 4.
Exactly. So log 10 over log 4. That's exactly right. Remembering, of course, that when we type it in, we have to close the parentheses after the 10. It's a good idea to close it after the 4 but since that's the end of the problem, it isn't necessary. It is absolutely necessary to close that. So log 10, close parentheses, divided by log 4. Did you get 1.6610? Remember, 0.66096, we're cutting it off right here. Since this is more than half, that has to get rounded up, so it makes it 10. 1.6610. All right, do you think you can try C by yourself? 1.73 to the x equals 9.72. Let's take a minute and have everybody try that one on your own. It's just like this one, do it exactly the same way. .1491. How does that sound? Is that good? There's a thumbs up. Anybody have a question about that? Anybody not get 4.1491? Okay, well, let's try one more. D looks a little bit different. I want you to look at D and tell me, Leah, can you tell me how you think we ought to start letter D? Look at it carefully. We've talked about this.
Well, there's no log in it, so you need to put that in.
We are going to definitely put the log in, but we have to do something else first. Does anybody see what we might need to do first?
Divide by 6.
Exactly. Remember, kids, it's been kind of a common theme. If there's a coefficient out in front of your problem, no matter what your problem looks like, if there's a coefficient out there, let's divide it out. So 2 to the x plus 1 would equal 3 if I divide both sides by 6. Does that make sense to everybody? Now, Leah, you're exactly right. I need this exponent to come down, but I can't bring it down until I have a logarithm in the problem. So I'm going to take the logarithm of both sides. Do not forget both sides, gang. Got to take the logarithm of both sides. Now I'm going to pull the exponent off. So x plus 1 log 2. Now don't panic because that's an x plus 1 quantity. Don't panic. Pull it off just like always. Now, thinking about the other problems we did, like over here, what do you think might be my next step? I'm going to divide by log 2. That's exactly right. I'm going to divide both sides by log 2. Just like I did before. I'm going to get my logs together. So x plus 1 equals log 3 over log 2. Now I can go ahead and type that in, just like I typed in all the rest of them. Log 3, close parentheses, divided by log 2. And before, this was the answer, 1.5850. This is another kind of tricky one, 1.58496. Remember, this is the break, this is where we're rounding, so that brings 49 up to 50. And before we were done, that was our answer, but not this time. What are we gonna have to do this time?
Subtract 1.
Exactly. So x is gonna end up equaling 0.5850. Subtract 1 from both sides. I think that's enough for today. What do you think? I know you'd love to do more, but I'm going to pause here and I'm going to remind you, you do have homework due today. Let's get it done. If you don't have it done, don't know how to do it, don't remember how to do it, then you need to show up at Flex, and Flex starts at 2:10 today. So set your timer and zoom back in at 2:10. All right, guys? So happy to see you. Have a great day.
Thank you, Miss Ford.
Goodbye.
Thank you.
Thank you.
Bye-bye. Antoine, you need to wake up. Hey, Pharaoh,